Okay, chapter 5, it's looping. We have been working with two structures, the top-down structure and the selection structure. In the top-down structure, remember, all the instructions are going to be executed only once, and each one of them will be executed. When we have the selection structure, is when we can skip instructions. Remember, this is what we implemented with the if statements, with the if, with the switch, with the if operator. So now we're going to be able to repeat the instructions more than once. And this is what we call looping. So we're going to be introduced to the loops. Of course, the first one is going to be the while. One of the implementations of the while is the input validation. We did input validation with an if statement, but every time that the user made a mistake, we had to stop the program. We had to add the code return 0 so that we can stop and ask the user, okay, if you want to start it again, you have to start the program again. You have to run it again. With the while, we are going to be able to ask the user, hey, you made a mistake, please resubmit your answer. If they make a mistake again, we are going to be able to ask again, please resubmit your answer. And we don't have a limit. We don't have a limit. We can do this so that the user can make as many mistakes as they want until they get it right. And this time, we don't have to stop the program. Okay, we don't have to stop the program. So it would just be asking the user, enter your answer, enter your answer, enter your answer. We're going to be working with an operator that is going to be incrementing and decrementing in units of 1. And this is useful because sometimes we don't want to stay like an hour with the program running and asking the user, type your answer again, type your answer again. So we can just count how many times do we want to let the user do this, like 5 times. Try it 5 times. If they don't get it right, stop it, because we know that they are never going to get it right. So we do this with the increment and the decrement operators. So we're also going to be counting. So that is section number 5.4. And then we're going to do a variation of the while that is called the do while. We're going to do another type of loop that is called the for loop. And the for loop is very systematic because we can initialize, we can increment, and then we can ask. And we can decide how many times we want to do a loop. When we do loops, this also helps us like to add like sales. Let's suppose that we're going to be asking the user enter the sales for the month, and every day they have a different value, right? Monday they sold $300, Tuesday they sold $200, Wednesday, and so on. For each day of the month they have a total for that. So we want to add all those together. One of the implementations again is going to be in a loop because we're going to be repeating those instructions, the addition. So that is called keeping a running total. We're going to implement the loops using that. Sentinels, they are like flags. They're going to help us stop the process or continue with the process. And of course, now that we know 3 types of loops, because we're going to be learning the while, the do while, and the for, we have to decide when to use which one. So we're going to discuss that. We can use nested loops, one inside another. It doesn't matter if they are different types. I can put a while, and then inside the while a for, and then inside the for a do while. That is correct, and we call that nested loops. Sometimes we do need to break out of the loop, so we need to know how to do that. And we're probably going to stop right here in 5.11. Okay, and we'll leave the files, data storage for your PF2. So we start with introducing the loops, the while loop. A loop is a part of a program that may execute more than one time. Again, remember, when we type a program, it will only execute the instructions once, right? Right now, we can skip some instructions with the if, but at least the rest of the instructions will be executed once. Now we're going to be able to execute a group of instructions. It can be one, it can be a block, more than once. So how are we going to do this? We're going to implement the while, okay, by using the word while is going to be a keyword, and then in parentheses a condition. We already know how to set up conditions. We know that we can use the relational operators and the logical operators. So we can use the less than, the equal to, the greater than. We can use the not, the nor, and the and, right? So we can use all that. So, and then inside the curly braces, we're going to be putting a block. This is the block that is going to be indicating these are the instructions that you're going to be repeating. How many times is this going to be repeated? Well, it's going to be based on the condition. It's going to be based in the condition. The way that we're going to read it is going to be while the condition is true, do this section. So here we have it. The condition is going to be evaluated. If the condition is true, the statements are executed. So it's like we're going to have a condition. So we have a question right here. Let's suppose that we have x is going to be greater than 5. That's our condition. And we start by setting an int of x is going to be set to 1. So we start. And we have here is going to be x is going to be set to x plus 1. This is our, let's see. Remember, if it's true, the statements in the block are going to be executed. So everything that we have in the block. When it gets to the end, it goes back and asks for the question. Okay? So let's see here. X is set to 1. And then we have the condition. Is x greater than 5? No. So what happens? Do we go inside the block? No. We skip the whole block. So how many times do we go inside the block? 0. None, right? So we never go inside the block. Okay, now let's suppose that we have the condition is x equal to 5. Double equal signs. How many times do we go inside the block? 0. We never go, right? We start x is going to be set to 1, and then we're going to be asking, is x equal to 5? No. So we don't go inside the block. So now let's say it's x less than 5. We're going to put it in less than 5. Yes, we go inside the block. How many times? One time? Let's see. Remember, if it's true, it's going to go inside the block. When it gets to the end, it's going to go back and it's going to ask again. And then depending on the result, it's going to go in or it's going to skip all those instructions in the block. So let's suppose x is going to be set to 1. And then we have, is x less than 5? Yes. So we go inside the block, right, which is right here. And we have one instruction only, that is x is assigned the value of x plus 1. What happens here? Let's suppose that we have x here. X is going to become a 2. So it hits the end and it's going to go back. And it's going to ask again, is x less than 5? It is, right? So what happens? We go inside the block. So this is the second time that we go inside the block. And we have to do this statement. X is assigned the value of x plus 1. What happens to x here? It becomes a 3. Gets to the end of the block, goes back, and is going to ask, is 3 less than 5? Yes, it is. So again, we go inside the block, and we're going to increment x by 1, right? So now we have a 4. Hits the end, go back. Is 4 less than 5? It is. So we go back in. This is the fourth time that we go in. And now we're going to be adding again 1 to x. So now x is going to become a 5. We hit the end and we go back. So now we ask, is x less than 5? No. So we stop. How many times do we go inside the block? 4 times. So we did a loop. Okay? We did a loop. Repeating the instructions 4 times. What was the instruction that we were repeating? Just one, this one. So we also call this an iteration. It's an execution of the body loop. So we did 4 iterations, right? We went inside the block 4 times. So the condition is going to be key here. Sometimes we can have an infinite loop. And we have to be careful. Let's suppose that we do the same thing. But we, instead of having this statement, we're going to have cout x. How many times are we going to go inside the loop? We start by setting x is equal to 1, or x is assigned the value 1. Then we have our loop. While the condition, and then the condition is going to be x is less than 5, do this statement. And the statement is cout. How many times are we going to go inside the loop? 4?
So x will continue being 1 no matter.
Exactly, right. We never change x. So how many times are we going to go inside the loop? Infinite. So guess what? We're going to get a screen that is going to have 1, 1, 1, 1, 1, 1, 1, 1, and then it fills the screen, and then it's going to start again. 1, 1, 1, 1, 1. So the user is just going to see ones on the screen. Have you received that? Sometimes when you run a program, never? Yes, sometimes it happens. It has a glitch. It has a bug, that program. So we go into an infinite loop. So what do we need to do? Control, Alt, and Delete, right? To stop the execution and exit that program. So that can happen very often. So we need to make sure that it's never going to happen to our programs. Here's just a flow of control, how this is going to work. It's exactly the same thing that we were discussing right now. So we have a condition right here. When it's true, all the statements in the block. Remember, all the statements in the block. And then we go back and ask again. When are we going to exit? When it's false. So here we have an example. How many times do we go inside this loop? And we have the answer right here. So we have value is set to 5. So we have a variable that is called val, and it's a 5. And we ask, is 5 greater than or equal to 0? It is, so we go inside the loop, right? And we are displaying the value of val. So here it is, it's a 5. And then we subtract 1. So now we have a 4. And we hit the end and we go back. Now we're comparing, it's 4 less than or equal to, it's greater than or equal to 0. It is. So back inside, we display val, which is a 4. And here it is. And then we decrease the value. Now we have a 3. And we go back. And now we have a 3. Is 3 greater than or equal to 0? It is. So we display the 3 and we decrease. Now we have a 2. Go back. Yes.
I have a question. For the value, why is it put this one?
So that they can leave a space.
Oh, okay.
Value and then a space. Because they are doing it on the same line. So they are displaying the 5 and a space, the 4 and the space, the 3 and the space. Okay. So we go back. Now we have a 2. Is 2 greater than or equal to 0? It is. So we display the 2 and the space. Right? And then we subtract 1. We go back. Now we have a 1. Is 1 greater than or equal to 0? It is. So we display the 1 and the space. We subtract. Now it's a 0. We go back. Is 0 greater than or equal to 0? Here they combine the greater than the equal to. And the answer is true. So we display the 0 and the space. We subtract. Now we have a negative 1. We go back. And now in -1, is it greater than or equal to 0? No. So it's false. So it's going to skip from here. It's going to skip the block, and it's going to continue with whatever statement we have underneath. We call this a pre-test. The while is a pre-test. Why? Because the condition is going to be evaluated before the loop, before we enter the loop. We know that if initially, and that was the first example that I gave you, if it's false, we never entered the loop, right? And this was the first example that I gave you, this one right here, when it was greater than 5. And it was not, so it didn't go inside the loop. When it was equal to 5, it was not, so it never got into the loop. So remember the infinite loop, we have to be careful with that. Because if we don't, then we're going to go into a loop that is infinite. Okay, some common errors that we have to be aware of. Don't put the colon, the semicolon, immediately after the condition. No, we never do that, right? Only the instructions inside. It's just like the if. We don't use a semicolon. Don't forget the braces. Like in this case, they have int, number of entries, is set to 1, and then they have while. Okay, if it's going to be 2 instructions, we need to put them inside the curly braces. If it's only 1, that's fine then. But this, if I don't put the curly braces here, is going to give me an error, because then number of entries is never going to change. Of course, don't use 1 equal sign when it's supposed to be 2, when we're testing for equality. This is just how we need to indent, just like we indent the lines when we're using if statements, programming style. One of the implementations of the while is in the validation. In the validation, like I explained, is the user is going to give us a value, and we need to make sure that it's going to be correct, right? Like we ask the user, okay, enter the number of units, and we know that the number of units can never be less than 0 or 0. Okay, 0 or less will be incorrect. Units that they buy must be a positive number. Positive 1, 2, 3, etc. So we can ask if the units are less than or equal to 0, then we're going to stop the program, right? We can stop the program. If not, then we can continue with the execution. But that is only giving the user one chance. One chance, one opportunity. They missed it, they give us a wrong answer, we stop the program. And we know that that is not correct. We need to give the user more chances, right? We need to do this. So that's why we're going to be doing a loop. So we're going to be asking, here the key is going to be, if the answer is incorrect, if the answer is incorrect, we go inside the loop, and the loop is going to tell the user, hey, you made a mistake, but give me the answer again. So they provide the answer again, and we go back and we check, is the answer incorrect? And if that is true, we go inside the loop again, and we say, hey, your answer is incorrect, give me the new answer. And then we go back to test it, that new answer. If that new answer is again incorrect, we go back in. But when the answer is correct, we exit. We exit. So that's what we want. So this is the way that we're going to do. Prompt for and read the data, whatever the input is, the number of units, the age, the code, whatever we're testing. Then you say, use a while loop to test if the data is valid. Okay, and here enter the loop only if the data is not valid. Only if the data is invalid. That's when we want to say inside the loop. Inside the loop, display the error message, just like I was telling you, and then prompt the user to re-enter the data. The loop will not be exited until the user enters valid data. Here's an example. Enter a number between 1 and 100. And I will guess it. That's what the computer is telling the user. So now the user is going to enter the number. Let's suppose that they enter a 0. So we have while the number is less than 1. Less than 1 will be incorrect, right? Because we want 1 or more. But my limit is until 100. If it's over 100, it will be incorrect. So if it's less than 1 or greater than 100, this is incorrect, right? So that's what we're testing right here. If it's incorrect, we go inside. So we tell a number must be between 1 and 100. Please re-enter your number, and we ask the user again. We give the flashing cursor indicating give me an answer. They type a new number, hit the end, and then go back. Let's suppose that the second time they type 101. Again, we're going to test. Is the number less than 1? No. Is the number greater than 100? Yes. So this is true. So we go inside, and we're going to say again, your number is incorrect. The number must be between 1 and 100. Re-enter your number, and we flash the light again, asking for the user to input something. This time they type a -3. We go back in. We display again, number must be between 1 and 100. Please re-enter your number. And we flash the cursor again, asking for the user to type. This time they type a +3. We go back in and we ask, is the number less than a 1? No. Is the number greater than 100? No. So now this is false. What happens? We break the loop and we go to the next line, whatever that is. So when we validate, we're going to be asking the opposite of a correct answer. We can do it this way, or we can use the not operator. Okay? Let's try it with a program. Questions? I want you to open up the code for the magic dates. You already have that program? Yes, open your code because we're going to change that one. We're going to implement this loop in that program. Okay, here's the magic dates. We already have the program, you already have the pseudocode, so we're not going to be doing that because we already have that. But I want to read again this information right here. The date, June 10, 1960, is special because when we write it in the following format, the month times the day equals the year, right? Write a program that asks the user to enter the month in numeric form, a day, and the 2-digit year. The program should then determine whether the month times the day is equal to the year. If so, it should display the message saying the date is magic. Otherwise, it should display a message saying that the date is not magic. Input validation, here it is, okay, our key. We're going to be validating. Think about legal values that the program should accept for month and day. So what are the legal values for the month? It has to be between 1 and 31, 1, right? Excuse me, month. It's 1 and 12. And then day from 1 to 31. So we're going to implement this validation using a loop now, not only the if. You implemented the validation using the if, but we're going to do it now using the loop. So I'm going to open Notepad and I'm going to code there the 2 instructions that we need. And you're going to copy those instructions and put them in your program. Make sure that it's C++. Here it is. Okay. So we know that the month is going to be prompt for. So we can put a cout. This is not C++ because it's not giving me the correct file. Language. C. Yeah, it is. There we go. Cout. We're going to be asking the user, give me one of your couts that you have for asking the user for the month in your programs. A what, I'm sorry? The month, no, the month in numeric. That's it? Okay. Close it. And then we have a cin, right? What variable did you use for that? Month. Okay, so you already have everything else, right? I'm just coding that section. Following the instructions that we have in the PowerPoint. First, display the prompt, right? Second, ask for the user to input. Third line, it has a while. While. Now, we're going to be testing here. When will this be correct? If the month is between 1 and 12. So that means it's equal to 1 or greater than 1, right? Or equal to 12 and less than 12. If it's within that range, then that means it's correct. So what do we want to do here? I'm going to put my curly braces because I have to set up my block right away. Uh-huh. Less than 1? Okay. Mm-hmm. Greater than 12? Okay. Okay, if month is less than 1, okay, or month is greater than 12, what do we want to do? If this is true, we go inside the loop, right? So what do we want to do inside the loop? This is an incorrect answer, right? Okay, we display, right? With a C out. Incorrect input. Please try again. And then C in. We cannot forget the C in, because if we forget the C in, guess what? We're going to have an infinite loop. Because the value for month never changes. So we need to ask the user, give me again month, to see now if the answer is correct this time. Okay, let's implement this in your code. Instead of the if that you have there, you're going to implement this. Remove the whole if with the block, and let's add this. And we're going to run it and see how many times you can make this loop with an arrow. Got it? Okay, let's do now the validation for the day. This was for the month. Again, we follow the same steps. First, we have to ask the user to input. So we're going to display a cout. And we're going to be asking, I'm going to use the same. Please enter the day in numeric form. Semicolon. And then we're going to ask the user to enter the day. What variable did you use? Day. Okay. And now we're going to do the while. While. And we're going to do our curly braces right away so we don't forget. What is the question here? What are we testing? Day, right? And we want to make sure that the day is between 1 and 31. So it's going, if it's correct, it has to be equal to 1 or greater than 1, or equal to 31 or less than 31. So we are going to be testing for an incorrect answer, right? Just like we did with the month. So here is going to be day less than 1 or day greater than 31. Will it make a difference if I put greater than or equal to 31? Will that be correct? No, because 31 is the correct answer. So we're going to close it here. And inside the loop, we're going to have an error, right? So we're going to, again, send the user the message, hey, this is incorrect. Incorrect input. Please try again. Semicolon. And then we're going to be asking for the day again. We have to ask for the day again. If we don't ask for the day, this is going to be an infinite loop. And we're going to send incorrect day, incorrect input, please try again, incorrect input, please try again, incorrect input, please try again, infinite number of times. So we need to stop it. Implement it and run the program, please. Okay. Questions on the loop and the implementation for validation? Okay, we're going to continue. This is the increment and the decrement operator. Sometimes when we use loops, we have to stop not because it's correct or incorrect the answer that they give us, but because we got to a limit. Like I was telling you, how many times are we going to allow the user to make a mistake? 10 times, 20 times, 500 times, 3 hours of tryout? Or we're going to be just saying, okay, after 5, that's it. We're going to close the program. I'm sure you have experienced this, like with passwords. They give you a chance, okay, type your password. Sometimes the system is very restrictive and they just let you do it 2 times or 3 times and then that's it. If you have to reset your password and you have to call the administrator, right? And call the bank or something, right? Because we exceeded the number of times that the program gave us a chance to make a mistake. So for that we have to count how many times we're doing it, how many times we go inside the loop. I go inside the loop once, so I have to increment by 1, right? That counting is incrementing by 1. I go in the loop again, I increment by 1. My 1 was incremented by 1, so now I have a 2. So, and the way that we do it is we use the assignment operator, right? When we're counting, we use this. Let's suppose that we're using x. We put x, it's assigned the value of x plus 1. Where x started with a 0, right? That is counting. Because the first time 0 plus 1, and then x is going to be a 1. The second time is going to be 1 plus 1, and then x is going to be a 2. And then the next time is going to be 2 plus 1, and then x is going to be a 3, right? That's counting. Well, we have another method that we can use, and that is called the increment operator. And just like we can add, we can also subtract. Start at 5. So I'm going to give you 5 chances. So 5, 4, 3, 2, 1. That's also another method, right? So we can also decrement, and it's called increment or decrement, reduce the value. To do it, we use, to add, we use 2 plus signs. So it's like the x and then plus plus. This is a shortcut for x is assigned the value of x plus 1. Very short method. And the same thing, if I'm going to put x is going to be decreased by 1, negative, I can put x minus minus. And it's always going to be 1. It's not valid that I put x plus plus 3. That is incorrect. It's always going to be a 1, incremented by 1 or decremented by 1. The plus plus or the minus minus can be used prefix mode, that means before, or postfix mode, after. So I can put x plus plus or plus plus x. I can do it that way. But it's going to make a difference. Let me see, we have it here. Yes, we have it here. The postfix mode, here it is. It's going to be after. So it's going to increment before the end of the statement, okay? Before the solution of the statement. In this case, we're going to have x is assigned the value of 1 and y is assigned the value of 1. So we have x, which was 1, and then we have y, which is 1 plus 1 is going to be a 2, right? And then we display the x. So x is going to be displaying a 1, and y is going to be displaying a 2. Why will this be so? Mm-hmm. They're adding 1 to y. But then whatever we're saying, move this to x. The assignment happened first. That's correct. The assignment happened first. So first we're going to be assigning the y to the x, and then the increment is going to happen. If I had put plus plus y instead of y plus plus, then it will be the other way around. It will be, the end is going to be 2 and 2. It's going to be adding first, and then it's going to be assigning. So remember, if it's going to be on the left-hand side, it's going to always be adding or subtracting first. If it's going to be on the right-hand side, it's going to do it after the statement is finished. After the statement is finished. We can, this can be used in arithmetic operations. We're always going to be using it just with the variable. Okay, we can also create counters. Okay, just like we can use the increment and the decrement, we can also create counters. And a counter is going to be a variable that is incremented or decremented each time a loop repeats with the same value. Okay, with the same value. Now, with the increment operator and the decrement operators, I can only add one, right? But here I can count in sets of 5. Look, so I can start x is going to be set to 0, and then I can set x is going to be set to x plus 5. So now the first time that I enter here, x is going to be a 5. If I repeat this line again, it's going to be a 10. If I repeat this line again, it's going to be a 15. If I repeat this line again, it's going to be a 20. So I start at 5, 10, 15, 20, right? My increment was of 5. So this we call a counter. Counter is x. So here we have, it must be initialized before entering the loop, may be incremented or decremented inside the loop, or in the loop test. We can also do it in the loop test. And this is going to be controlling my loop. We use counters to control our loops. And let's see an example here. We have int num and int limit, two variables. We have two boxes. They are ints. And we ask, okay, table of sugars. It's in one line. Second line, how high to go. And then cin, it's a limit. So we're going to be asking for a limit. Let's suppose that we get in a 3. And we're going to display cout, number, square. And then in num, we're the other way around, I'm sorry. 3, and this is going to be a 1. And we're going to say, okay, do this while num, which is 1 right now, is less than or equal to the limit, which is going to be 3. Is this true right now? Yes, so we go inside the loop and we're going to be displaying num, which is 1, and then num times num. So it's going to be 1 and 1. And then we increment the number of num by 1. So now num is going to be 2. Go back to the while. Now we compare is 2 less than or equal to 3? Yes. So we go in and we display num, which is going to be 2. And 2 times 2 is going to be 4. We increment the value of num. Now it's going to be a 3. We go back and we ask, is 3 less than or equal to a 3? It is. So we go back in and we're going to display 3, which is num. And 3 times 3 is going to be 9. We increment. Now it's going to be a 4. We go back. Is 4 less than or equal to a limit? No. So we skip all this and we exit. So we display 1, 1, 2, 4, 3, 9. So we're playing what? The square, right? This is the table of squares. We're squaring the number 1. We're squaring the number 2. We're squaring the number 3. How many times are we doing it? Well, it depends on how high to go. They're asking us. And I put a 3. We can go to 100, and that will be our limit. It will give us a table with 100 numbers. We can go to 50, and it will give us a table with 50 numbers. So this is another implementation of the loop. We can also accumulate inside the loop. I'm going to skip all the way to the accumulation. There we go. Keeping a running total, which is also accumulating, okay? We accumulate sum of numbers for each repetition of the loop. Now, we were doing it with counting ones or counting in fives, right? But when we do an accumulation is the first time I can get a 40 plus 40, the second time I can get a 20, the next time I can get a 10, the next time I can get a 3. I don't know what number I'm going to be getting. So this is called keeping a running total or accumulating. The variable that is going to be keeping track of this is called an accumulator. So if I put sum is going to start by setting being equal to 0. And then I have sum, it's assigned the value of sum plus 40. So now in sum I have a 40. But then when I add sum, it's assigned the value of sum plus 20, it's going to have a 60. When I put a sum, it's assigned the value of sum plus 10, it's going to have a 70. And then when I run sum, it's assigned the value of sum plus 3 is going to have a 73. But this value right here, I'm doing it with a number right now, but it can be something that the user gives me. This can be y, and y the first time was a 40, y the second time was a 20, y the third time was a 10, and y the fourth time was a 3. And we did a loop 1, 2, 3, 4 times. And we can do it this way, or we can do it the shortcut way, right here. Plus equals, right? And it will be the same. In this case, they are doing sum is going to be set to 0, and then num is going to be set to 1. Where sum is the accumulator. And we're going to be repeating this line 10 times, or this loop 10 times. By doing what? By accumulating sum into num into sum. I'm going to do it 3 times only, because 10 times is going to take us a long time. So we're going to see here what happens. So num is set to 1. Is 1 less than or equal to a 3? It is. And then we have here sum is assigned the value of the sum of sum plus num. So we have sum is a 0 plus 3. Let's see, plus 1, excuse me. 1 plus 0 is 1, and we put it in sum. So I'm going to put here sum. It's a 1. We increment the value of num, so now we have a 2. I'm going to take it off from there. And go back, and we're going to say, is 2 less than or equal to a 3? It is. So we're going to add now whatever I have in sum, which is 1 plus a 2. 1 plus 2 is going to be a 3. That's what I leave in sum. And then I increment the value of num. Now I have a 3. Go back, and I'm going to ask, is 3 less than or equal to a 3? It is. So now I add sum, which is a 3, plus the 3 that I have in num is going to be a 6. And then I increment num. So now I have a 4. Go back and ask, is 4 less than or equal to a 3? It's not, so we display this. Sum of the numbers 1, 2, 3, because that was our limit, right, is 6. Is that correct? A 1 plus a 2 plus a 3 is going to give us a 6? Yes. So what are we doing? We're keeping a running total. Every time that we are adding here, it was a different number. We're not counting. That is the difference. Questions?